classic type of question whenever you're talking about maximizing or minimizing things. This is your open top box problem where we have a flat sheet of some type of material. In this case, it's tin. We're going to be cutting boxes out of each corner that are of the same length. So you're going to be cutting X by X squares from each corner and bending up the sides. And we want to know how large those X by X squares should be to make the box hold as much as possible. If we are holding, that's going to be volume. So remember, volume is going to be your length times your width times your height. So I have my two-dimensional piece of material. I'm cutting X by X boxes out of each side. I guess I should do that like that. So that's going to be X and X, and that one is going to be X and X. Now before cutting, this entire side is 25, and this entire side is 20. Now when we're cutting, and this is very similar to the previous question where we were putting the rectangle underneath the sine arc, I'm going to be taking an X from the left and an X from the right, which means my new length or width, or whichever unit you want to call it, of this box is going to be 20 minus 2x. This distance, because again that's the same with that 25, is going to be 25 minus 2x, and then my height of my box is actually going to be x. Now I'm going to scroll down a little bit just so you can see the three-dimensional drawing of this. Let's see how this three-dimensional drawing goes. Here's my rectangle here. This is going to be, make that a little bit better. Okay, so the X is what I cut out of each side. This distance here then is going to be my 20 minus 2x, and this distance is going to be my 25 minus 2x. So whenever I fold that up, again, you can see there's what my box looks like. It has no top on it. So I don't need to worry about surface area. Surface area, you would actually be finding the dimensions of each of the sides of this, but this is volume, so we are going to be folding each of these sides up. So the volume in this situation is going to be 25 minus 2x times 20 minus 2x times x. And you would have to actually go through, I would suggest multiplying all of those together. I'm going to do a shortcut and show you what the answer is once you multiply all those together, just to save some time. So this is going to multiply to 4x cubed minus 90x squared plus 500x. So that is my equation for the volume for this open top box. Now again, I am going to be optimizing in a maximum way. So I'm finding the maximum of this, or the maximum possible volume. So I need to take the derivative, because when we're maximizing or minimizing, we need to have a derivative. So that is going to be 12x squared minus 180x plus 500. We would set that equal to 0. You could make this a little bit smaller because all of these terms do divide by 4. So you can think of this as 3x squared minus 45x plus 125. This does not factor, unfortunately, so you could put this into a graphing calculator and see where it would cross the x-axis. You could also use the quadratic formula, which would give you 45 plus or minus the square root of 525 over 6, and you get two different x values here. We get 11.32, and we get 3.68. Now, before we figure out what our correct answer is going to be, you should always consider what the domain of your possible solution is. Kind of like, again, in the previous question where I told you were looking for an x value that was in between 0 and pi over 2. If you think about it with this question, x cannot be an unlimited size. Because if x was unlimited, eventually you would make it so that you're cutting more than is there to cut. Look at the 20 minus 2x, for example. That is the width. So if I was cutting out an x that was, say, 15, that would be putting me over halfway from my rectangle. 20 minus 2 times 15 is 20 minus 30, which gives me negative 10 as my remaining unit. And it's not possible to have a negative side length whenever you're dealing with any type of real world problem, or anything having to do in the real number system. So there is a limit here to how big x can be, and x can't be bigger than 10. You always want to go by the smaller side. So this 25 minus 2x, that's going to be our longer side. The 20 minus 2x is the smaller side. 10 is the absolute biggest that x could be, and even if x was 10, that would give you a side length of 0. So most likely that's not going to maximize volume whenever one of your units is 0. So x does have to be in between 0 and 10. Technically, it could include 0 and 10, although if it was 0 or 10, one of your dimensions would be 0, so that's not actually going to give us a max. It would give us a minimum. So if I look at my two answers that I have here, the 11.32 is going to be crossed out because that does not fall within the domain of our question. So 3.68 is going to be one of the dimensions of our box. And notice this does not actually ask us for the dimensions. If it did want the dimensions, I would plug this 3.68 in for both of the x's, well, all three of the x's, to get the overall value. This wants how large should the squares be. So the square should be 3.68, let me see here, what are my units? Inches. So 3.68 inches. And then for the volume, that is going to be 820.53 inches squared. And again, I should probably have 3 decimal places with these. I, for some reason, don't have those on my paper, so that's why you don't actually see those other values. Technically, 0 and 10 are part of the critical values, so you can include them if you want, but they are both minimums. Whereas this one is going to be the maximum. The last example we're going to look at in this section deals with a cylinder. This is a really great question, and you have one like it in your homework, but it's changed a little bit because I believe in your homework you do not have a top. So you still have a 1 liter oil can that is a right circular cylinder. This one is going to have a top and a bottom, whereas the one in your homework is only going to have, I believe, a bottom. So that's going to change things a little bit. So notice it says what dimensions will use the least material. So we are minimizing instead of maximizing. So I have my cylinder. If I am creating this, if I want to use the least amount of material, that is going to be surface area. Surface area is going to be what you would use to create the outside of it. But notice 1 liter is a volume. Now, there is an interesting connection here that you do have to make, and that's the fact that 1 liter can be converted to a unit of measurement as far as length goes. And I don't know if you remember this from science or not, but 1 liter is equal to 1,000 cubic centimeters. So you have 1 liter is equal to 1,000 cubic centimeters. That is going to be your volume. That's going to be our volume. So I'm going to mark a couple of things on here. The radius is important, the height is important. These are going to meet at right angles because it is a right circular cylinder, so it's not leaning one way or the other, it's going to be straight up and down. So my volume is going to equal 1,000. Notice this is going to be in centimeters. My volume is going to equal 1,000. The formula for volume of a cylinder is pi r squared h. Surface area, which is what I'm actually going to be working with, what I'm actually going to be taking the derivative of. For your surface area, you have a top and a bottom that are circles. The area of a circle is pi r squared, so that's going to be 2 pi r squared. Around the outside edge of a cylinder, if we were to slice this and open it up, it's actually going to be a rectangle. It's a rectangle where the height is going to be h, and then the length is actually circumference. Because it is wound around in a circle, your circumference is actually, whenever we straighten it out, your circumference length is going to be the length of this rectangle. And that is 2 pi r. So h times 2 pi r. Now, the problem with this, and we're gonna learn how to deal with this problem whenever we get to 5.6. But the problem with this is I can't take the derivative of surface area as it is because I have 2 different letters here. I have an r and I have an h, and both of them represent variables. In order to fix that, I need to go back to this volume formula and either rewrite r in terms of h or h in terms of r. And the easiest way to do that is going to be to solve this equation for h. Since there's only one h to plug in for, it's going to be a little less work if we go about it this way. So my h is equal to 1,000 over pi r squared. So this formula is now going to become 2 pi r squared plus 2 pi r times 1,000 over pi r squared. And I can actually go through and simplify that a little bit before we take the derivative. Because my pi's can disappear, I'm going to multiply the 2 and the 1,000. This r is gone, that r is going to become to the first power. So my surface area equation cleaned up is 2 pi r squared plus 2,000 over r. Keep in mind r has to be greater than 0 because we cannot have a negative radius. So now, let's find the derivative of surface area. So that is going to be 4 pi r. This r is really r to the negative 1, so this is going to be minus 2,000 r to the negative 2, which then I would set equal to 0. We get 4 pi r is equal to a positive 2,000 over r squared if I shift that r to the negative 2 back down. Then to solve, I'm going to multiply both sides by r squared. Give myself some more space here to do my math. So that's gone. So I have 4 pi r cubed is equal to 2,000. I would divide that by 4 pi, and so whenever I divide that, I'm going to get 500 over pi, and then r is going to be the cube root of 500 over pi, which is approximately 5.42. And again, that's centimeters. You could check to see if this is actually a minimum. If you take the second derivative using what we had up here on this line with the SA prime, you will see that you'll get something that's always going to be positive. It's going to be concave up, which means this is in fact a minimum. However, our question says what dimensions will use the least material. When you're naming dimensions for a cylinder, you don't just need the height, you also need to know the radius. So we do have the radius, which is 5.42, but now we have to plug back in to find the height. So if I come up to my height equation up here, I'm going to switch colors here. I have 1,000 over pi times the cube root of 500 over pi, and this is squared. This just looks like a big old mess. It doesn't look like it's really going to become much of anything. But if you do go through and simplify this, you actually end up getting I think this is 10.84 as a decimal. So you have 2 times the cube root of 500 over pi. It is twice the radius, and that's the important thing here. So for this particular problem, you want the height to be 10.84 and the radius to be 5.42. But the important thing is that the height is 2 times the radius. In order to minimize the amount of material that you're using, whatever your height is, the radius should be half of that, which makes sense because radius is half of diameter. So in order to minimize whatever materials you're using, your diameter and your height actually have to be the same thing. So I know that one might have been a little bit of a struggle to follow, and I think the book does a good job of explaining this as well. As I said, there is another question in your homework for this one, but instead of the surface area being the 2 pi r squared up here, it's just going to be a pi r squared because you have an open top can, which means you don't have that circle on the top. This one had the circle on the top and on the bottom. The one in the book is only going to have the circle on the bottom. So you have a nice template here to follow. This is the homework assignment for this section. Please pay attention to Schoology so that you know when this homework is due. This is a bit extensive, so please be sure that you're working through these questions. There's not a whole lot of them, and that's because they do take up some time. So go back through, watch this video, watch the first video, and reach out to me if you have any questions or have any misunderstandings that you need cleared up.